Now I'm going to draw the circuit for t larger than 0. Oops, my pen is not working. And what happens is that everything that is u of t, I'm going to use it as a volt, because as 1, because for t larger than 0. And everything that's u of minus t, I'm going to set it to 0, because it's also for t larger than 0. And I'm going to draw the capacitors and the inductors, because now I do want to write equations that include those voltages and currents. Let me see if I turn the light on, if it's better. I hope it's better. We'll see. So these two switches go to the right side. And now for sure the 10 milliamps and the 3 kilo ohms are out of the circuit with the capacitor and the inductor, so I don't need to draw them. But that 1 kilo ohm is still there. And now this power supply here is only 1 volt, because it's minus 2 plus 3. And this will be the voltage across the capacitor. And this goes to the 4K and to ground. So this switch is over here, it goes to 4K, and this goes to ground. This switch, the 2K, goes to this, but it's open. So u of minus t for t larger than 0 is 0. To guarantee that this current is 0, there's nothing there. So this would have been the current supply, but it is open. And this, the 4K, it's closed, that means it's shorted. So what happens is that this is a series circuit. And this is the thing that I wish we had done today in class, but we didn't have time. So that's why I'm doing it here. So now I'm gonna do it 5K, 0.2 microfarads, 4 henries. And now look, for a parallel circuit, we did the KCL. For a series circuit, we're gonna do KVL. And I'm gonna assume this current through the inductor is the same direction as this one. And actually it's the same current. So I'm gonna do V5, the voltage across the resistor, plus the V across the capacitor, plus the V across the inductor, plus 1 equals 0. This is KVL. And I have the VC because this is the VC that I found for t less than 0. And this one is going to be 5K times IL. And I also have IL of 0 minus, which is IL of 0 plus VC of 0 minus. Instead of VL, I'm going to write L di dt equals minus 1. I'm just going to put already the minus 1 on the other side. So now I'm going to use IL of 0 minus. This is minus 1.3 milli. And this guy is minus 33 volts. And L is 4. So minus 1.3 times 5 is minus 6.5 minus 33 plus 4 DIL at 0 plus DT is minus 1. So this is minus 39.5, goes to the other side, 39.5, 38.5. So DIL 0 plus DT equals 38.5 divided by 4. Okay, which is 9 point something. Let's 0.5 times 4. Yeah, it's like 9.6 amps per second. So this is the third initial condition. And then to find the C dV dt in a series circuit is much easier because I is C dV dt. And so at 0, I can call this IL of 0 plus equals C, which is 0.2, so 2 10 to the minus 7 dV dt at 0. So dVc dt at 0 plus will be that minus 1.3 divided by 2, 10 to the minus 7. Finally, dVc of 0 plus dt is minus 0.65 10 to the 7 volts per second, which is 6.5 million volts per second, or minus that actually. So these are the numbers that I've missed for today's class. For this question, find all initial values, but now it's asking also the final value. So let's do that one.